Hello, geometry. Today we're talking about 11.5 angle relationships. You should get your notes from the sub or they're on your Edmodo. In your first one, yours is going to look different than mine. It says the first theorem, if a tangent and a secant or chord intersect on a circle at the point of tangency, then the measure of the angle formed is half the measure of the intersected arc. So all that's basically saying is that here we have the tangent line BC intersecting at one point, and then you have, in this case, a secant, or if we were to cut it, then it would end up being a chord, and they're both intersecting on the circle. So the theorem says the measure of ABC is going to be half of the arc ABC. AB. Oh, this says X right here. That's supposed to be A. So of course we know that, just like yesterday we talked about the inscribed angles. So the inscribed angle basically creates the arc AC. So the measure of this angle is going to be half of the arc. So let's look at the first example. And let me scoot it up just a little bit. Alright, so your picture looks like this. We have the semicircle AC, and then we have the tangent down here, which is CD, and then we have a secant right here that's going through at B, and then we see the arc BD is worth 142 degrees. And the first question asks us to find the measurement of angle BCD. Remember I said the easiest thing to do is to highlight your angle, and so then that way you can be able to look and see what information you need. And here in this case we see that we need angle arc BD, and so we know the theorem tells us that the angle is half the measure of the arc. So if we know that the angle is half of the arc, our arc is 142, so we have half of 142. And so the answer is the measure of angle BCD is 71 degrees. Everybody got that? The second one tells us to find the measure of arc ABC. And if we highlight that, arc ABC is the entire arc. And this arc is attached to the semicircle. And we know semicircles are worth what? 180 degrees. So if we're trying to figure out the measure of the arc, we know that 90 times 2 is how we would get that arc, which is 180 degrees. So the measure of the angle is going to be equal to that whole semicircle, so the answer is 180. Everybody got that? Okay, let's flip over. Here at the top of your paper that you have the second theorem, which says if you have two secants, so of course two secants that intersect, or two chords that intersect at the interior of the circle, then the measure of each angle is half the sum of the measures of its intercepted arcs. On the other ones we only had one angle, but here this one creates two angles. So we have our angle 1 here and our angle 2 here. This is AC, and D, and so now we see that these two angles are creating two arcs. So if you're trying to find the measure of angle 1, it will be equal to the sum of arc AB and arc C. So you're trying to find this angle, you just add the two arcs. So that's why it equals half measure of arc AB plus the measure of arc AC. So to figure out the angle, take half the sum of the two arcs. And of course, if you want to find the measure of angle 2, so now we're trying to find this one, so then you would take half the sum of these two arcs. So then it would be half measure of AC plus the measure of, not angle, arc BD. Got it? So keeping that theorem in mind, two secants or two chords. Let's look at the next example. Here we're trying to find the measure of angle SQR. So we have two secants here. They're telling us that this arc is worth 32 degrees, this arc is worth 100 degrees, and we want to find the measure of SQR, so I'm going to highlight it to make it a little bit more visual. This is the angle that we do not know, but based off the theorem we just went over, in order to find the measure of angle SQR, we take half the sum of the two arcs. So we add 32 plus 100. And I'll pause for a second. How do you pause? Oh, there. All right, I'm back. So 32 plus 100 is 132. We take half of that and your answer should be 66 degrees. Got it? Okay, the next theorem, which half of yours is probably cut off. I think so. But it says if, and I think this is the part that's cut off, a tangent and a secant, two tangents or two secants intersecting the exterior of a circle, then the measure of the angle formed is half the difference of the measure of its intercepted arcs. So if a tangent and a secant, two tangents or two secants intersecting the exterior of a circle, then the measure of the angle formed is half the difference of the measures of its intercepted arcs. So then take a second to look at those. I have to pause it for a second. Another second. So if you remember on the theorems we just finished, we just had two secants that intersected, the angle was half the sum. So in this case, and you should have three pictures at the bottom. I'll draw the first one because I think it's cut off. Here we have a secant because it's going through the circle, and we have a tangent because it's intersecting at one point. And if we want to find this angle out here, and this one is 98 degrees and this one's 174, basically to find the angle, you're subtracting the bigger arc minus the smaller arc. So that one would be the measure of angle 1 is equal to this bigger arc, AD, minus arc BD. And this one is B. And okay, yeah, we already said that point was D. So to find the angle on one like this, big arc minus a small arc. On the two secants, remember we did the sum. Another example is, remember we said or it could be two tangents. So this would be an example of two tangents. And you would do the bigger arc, EHG, minus the smaller arc, which is EG. So this one minus this one will give you this angle. Angle 2 is, oh, I forgot on the first one. It was half the difference. I forgot to put the half on that first one. I'll go back. Yeah, I still have it. Half. The angle measurement is half of that one. Here we have half, so angle 2 is equal to half arc EHG minus arc EG. And the last example, so we've done a secant and a tangent. We've done two tangents. And now we're going to look at an example with two secants. And of course, remember, secants go through the circle. So example of two secants would be J, K, M, and N. So the measure to find angle 3 would be half arc JN minus arc KN. Got it? Please make sure you memorize it. It's easy. If you have two secants going through making a big X, sum, half the sum of those two will give you the angle. Now on the case like this, two secants, two tangents, or a tangent and a secant, remember it's half the difference. So please make sure you study those. And now let's look at some examples. Where am I? Oh, okay. Example 3, using tangents and secants. So you have a circle, and this one shows a secant and a tangent. This is P, X, 98, 174, R, and S. And it wants us to find angle S. Here, remember, it's big arc minus the small arc. So we have half 174 minus 98. And when you take half of that, the answer ends up equaling X equals 38 degrees. On the larger one, the next one, we have a circle with two tangents. This is X, F, E, G, 132, and H is out here. And what do you notice about this? Whenever you have two tangents, it's basically the two arcs are basically the entire circle, the sum of those two. So the fact that we only know this one is 132, we know that it all encompasses the whole circle. So if you want to figure out this arc, EHG, you do 360. So to find arc EHG, you do 360 minus 132. And so, my mind just went blank. 360 minus 132 is 260. Take away 30 is 230 is 229. Sorry, brain fart. Wait, no, not 229. Oh my, okay. Slow moment. Gotta go back to old school. 8. I'm tripping. 8, 2, 2. Okay, yeah, 228. Sorry. I know you're talking about me. I don't care. All right, so we have 229 is this larger arc, and so now to figure out the measurement of angle, we know it's half 229 minus 132, and so that mission angle measurement is equal to 48 degrees. Everybody got that? Any questions? Oh, I put 229 again. It's 228. 228. Right? Double checking. 8 plus 2 is 10. Carry the 1. 3, 4, 5, 6. 3 plus 1 is 2. Okay, just double checking before somebody email me. Tell me I got it wrong. All right, so that's 48. Any questions on that? Hope not. The last one is an example, a real life example of your pupil. So it says, when a person is farsighted, light rays into the eye and are focused behind the retina. In the eye shown, light rays converge at R. And I wonder, do I have a picture of that one? Nope, I don't, so I'll draw it. Light rays converge at R if measure of arc PS is 60 degrees and the measure of arc QT is 14 degrees. What is the measure of angle PRS? So here, of course, you know I'm not good at drawing, but I can draw an eyeball. Eyeball looks something like this. We see that what's going through the eyeball, guys, hopefully you said it, that is 2 secants. So here's the eyeball looking behind there. QT is 14 degrees. We're trying to figure out that angle measurement. This is QRT. We don't know the angle measurement. It tells us that PS, which is right here, is 60 degrees. That's the lights going into the eyeball. That is 60 degrees. Everybody see that? And so we want to figure out in the eye shown, okay, what's the measure of angle QRS? So we said that. So basically we have the big arc minus the smaller arc will give us the angle measurement if we take half of it. And so we do 60 minus 14, take half of that, and so the angle should be 23 degrees. Any questions on that? Nope. Let me check and see if this is still recording before I be talking. Oh, we got 1 minute left. I'm gonna pause and restart, and we're gonna come back with day 2.